just to hit up a little bit more intuition on the binomial expansion and Pascal's triangle and combinations and all that. In the last video, I just quickly wrote out what the binomial expansion for this guy was, but I didn't really talk about it too much. So we're going to explore it a little bit better in this one. All right, so just to review, if I have x plus y squared, that would be x plus y times x plus y. And when you multiply those out, you're going to multiply this guy, and that. And then you're also going to multiply this guy by both those terms, okay? So what you're going to get is you're going to get x squared for the first guy, these two guys, and then you're going to get an xy, right? And then you're going to start multiplying this y guy out, and you get a yx. And then you multiply that out, and you get y squared. Well, these two guys together, are the same thing, so they get 2xy plus y squared, okay? And just to continue that, if I had, well, x plus y cubed, right, that would be the same thing as this thing times x plus y, because this guy right here is x plus y squared, right? Okay, so if I did that, again, I'd have to multiply everything out by every other thing. So I multiply that, and then I take the 2xy and I multiply it by those two guys, and then I'm going to take the y and I'm going to multiply it by those two guys. So I got three things going on here. Okay, so the first one is x squared times x, which is x cubed. The second thing is x squared times y, which is x squared y. Now I'm done with this x squared. Now I'm going to focus on the 2xy. I multiply that out, I get 2x squared y. Then I multiply it by the y, I get 2xy squared. Okay, I'm done with that guy. Now I'm going to the y squared. Now I have y squared x and y cubed. Well, there's a couple things you should notice here. I put my x squareds together. Well, I've got 2x squareds here, and I've got 1 here. So together that makes 3x squared y, right? Doesn't matter. I mean, the y does matter, but in that case it's the same, so it's no big deal. Over here, I have a 2xy squared, and I have a y squared x. I have 2xy squareds, and I have 1xy squared. So that becomes 3xy squared. And then I just have my y cubed. Now, if you remember Pascal's triangle, look at the coefficients here. Right? The coefficients on this guy are 1, 3, 3, and 1. So, and what's the coefficients up here? It was 1, 2, and 1. So, and obviously the coefficients for x plus y are just 1 and 1. So this looks like that triangle. It's 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay. So what I had that I wanted to answer, well, what was x plus y to the fifth? And if you need to look at the combination videos, you should do that. But the first thing we're going to write out is all the combinations of possible groups of 5. So I have 5 to the 0, 5 to the first, 5 to the second, 5 to the third. I'm sorry, not 5 to the third. 5 choose 4 and 5 choose 5. These are combinations. I'm saying them wrong. So if you look at the triangle, the first row is 1, 5, 10, 10, 5, 1, right? Because the triangle will go 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. Just like this row right here, just like I have written out here, okay? So that 1, 5, 10, 10, 5, 1. When I put my x to the fifth, or I put my x component in there, it becomes x to the fifth, x to the fourth, x to the third, x squared, x, and then x to the 0. And then when I put my y's in there, the y's do the opposite. They grow. Y to the 0, and they always have to add to 5 in this case because I'm choosing out of 5. So 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 1 plus 4 is 5. And 0 plus 5 is 5. Okay? And now I want you to notice the balance that 5 choose 0 is the same as 5 choose 5. 5 choose 2 is the same as 5 choose 3. And it is all because the 2 and the 3 make 5. In any given scenario, n choose k is the same thing as n choose n minus k.